Distinguished guests, dear speakers, dear friends, we would like to begin by giving a brief background on what Real-Time Graduate is, which is the basic reason why we have so many young people joining us here today, and what we have been doing for the past year and a half. Well, we were established in 2016, and it's the first free access database for CVs in the maritime industry in Greece. Currently, we have approximately 1,000 registered graduates, more than 40 registered companies, including ship management companies, classification societies, among others. And we have more than 10 specialties: electrical engineering, accounting, maritime law, mechanical engineers, naval engineers. In this time frame, we've had approximately 62 direct CV requests, and more than 360 CVs have been sent out to cover these positions. Approximately 110 Greek universities, naval academies, colleges, and technological institutions, and more than 100 foreign university schools and colleges, including University of the Aegean, University of Piraeus, Alba Business School, National Technical University of Athens, Newcastle University, Cardiff University, and others. There are no fees for the graduates and the companies to join either way. And in this time frame, the past approximate year, we've had more than 45 internships and direct hires directly from Real-Time Graduates. Another point that we've tried to do was bring the younger generation closer to the shipping companies. In this time frame, we've arranged approximately 30 open house educational visits to some of the biggest shipping organizations in Greece, and shipping companies as well. More than 550 graduates have attended. And we've had a total number of approximately 55 speakers. Our latest visit, we were very proud to go to the Union of Greek Ship Owners, where we were welcomed by the President Theodore Veniamis and ex-President Mr. Liras, where 20 of our graduates had the chance to discuss one-on-one various issues facing the younger generation from a general perspective as well as a business perspective. So this is, considering how many specialties we have here today, we wanted to put together a speech and a presentation for everybody who's going to be going outside to the working environment now and in the future and in 20 years to come. So welcome to what we like to think is a glimpse into the future of shipping management. Shipping markets have become a lot more complex in recent years, with companies faced with intense competition and a plethora of often restricting regulations which need to be complied with. Digitalization has affected industries in the past years. However, the shipping industry is one of the last to grapple with it due to mainly the complexities of the industry itself. We have moved from the industrial age into the digital age with a huge leap in technological development. Data is collected on the go and processed intelligently. This allows for a whole new quality and type of communication where time and space are basically recalibrated. Although the maritime industry is still deeply traditional, its technology is rapidly changing. Many different innovations, solutions, and principles are being proposed and gradually integrated into shipping, such as sustainable shipping from an ecological perspective, alternative fuels such as LNG and biofuels, emission reduction of carbon footprints, unmanned and/or autonomous ships, big data analytics, networks of wireless sensors on board, ship-to-shore communications, and robotics and other artificial intelligence systems. There have been numerous discussions in general regarding the ship of the future. There seems to be little focus, however, on the fact that the ship of the future cannot operate with the ship manager of the past. Therefore, the ship manager of the future would have to be a company that would be fully equipped to handle the challenges brought along with digitalization. This would require further setting up and developing what we can also call control centers in order to manage these smart ships of the future and instruct and guide them to increase and improve things such as voyage efficiency by adjusting the operational parameters, safety by alerting the crew for any possible upcoming risks, ability to control a ship from a central position, decreasing the number of crew members needed on a ship, hence reducing labor costs. However, in order to attain the gradual upgrade of shipping to the so-called smart business model that I previously talked about, we need to have a drastic change in the mentality of the human resources in order to make the above principles workable. Therefore, an obvious challenge for the future of shipping, in fact, is the upgrading of the human factor culture involved in the maritime industry. This will require further introduction of new specialties, along with some of the specialties that we already have, which have been affected by data, tasked with the overall digital upgrade of the ship manager. Naturally, these positions, as well as the various roles that they take on, will vary based on the complexities of the operations, the size of the fleets managed, and the quality and skill set of the existing personnel. As you can understand, a large company which has 100 vessels would reap more benefits possibly by a small company that manages 3 or 4 vessels. That might lead us to see pooling of smaller fleets in order to reap the benefits of this shared knowledge. At this point, I would like to briefly mention what defines big data for those of us in the audience that might not be extremely familiar. Some of the defining features of big data, which is what digitalization is currently based on, is flexibility. Big data is flexible data. In the past, all specific types of databases stored and controlled data with the use of constant data structures. This isn't the case with big data, since fast data transformation is a crucial part in its use. Real-time results. All data is collected and has the ability to be stored in real time. That's what makes it so interesting. One of the most important components and uses of this type of data. Machine learning applications. Machine learning, which we'll be discussing a bit further on, is one of the cornerstones of the importance of big data, allowing the data collected to become predictive. An interesting point to note is that these particular innovations apply to various departments of a shipping company and not just to one. For example, big data analysis is when all this data is analyzed, which derives from the vessel, analyzed to the office in order to evaluate this data collected and put them to the best use for specific departments. Machine learning techniques. Various machine learning techniques are applied in shipping for monitoring the energy efficiency, faults diagnostics, predictive maintenance in order to achieve the vessel's most efficient operations. Artificial neural networks. Artificial neural networks haven't come even close to modeling the complexity of the human brain, but they are shown to be good at problems which are easy for a human but difficult for a traditional computer, such as image recognition and prediction based on past knowledge. Artificial neural networks are based on mathematical models simulating the way that the brain works. Therefore, when applied to a time series, they provide sophisticated forecasting methods, using either linear or nonlinear models. In comparison to other methods, they provide a viable alternative, in many cases yielding impressive results. A common difficulty with this type of networks is that only repetitive testing can answer the question of which network to use in each case. Some of the uses of big data in the shipping industry, for example, are predicting repairs and structural integrity, which leads to better planning of operation, less time lost, lower costs. Predicting of port say control results of the fleet, allowing for better planning. Self-piloting ships, less room for human error, which remains up to this day the #1 cause of accidents. Cargo tracking, which brings better delivery estimates, and cargo matching, again meaning less time loss and lower costs for the ship manager. Centralized knowledge, better accuracy for constant changing weather patterns. Current and future design of the vessel. Current referring to more efficient and cost-effective navigation. Future referring to better and more efficiently designed ships. Moving on to specific departments affected. At first glance, an obvious department of the shipping company that would be affected would be the IT department. At this point, we'd like to say that some of these positions already exist. As we said, we already have sensors on board. We already have smart ships sailing around the world. So many of these positions already exist. They will be evolved further. As the EU moves ahead with its data protection laws, the GDPR, companies are required to find positions specifically and security experts, data protection officers to comply with these regulations. All of this would come with a network of with a cybersecurity officer, considering how communications have grown and a Wi-Fi and 5G connectivity have created a fully connected ship. This platform, where all devices are constantly connected to the internet, requires a person to deal with any incoming threats at any minute. Big data and data analytics engineer. The problem with the big data that most companies face is not how to collect the data. This seems to be something that is currently happening anyway. It's not the data itself, but what companies will do with it once it's been collected, and how to evaluate them. Big data itself means nothing if there isn't the correct person responsible that has the skills such as sensor data analysis, data center management, predictive analytics, program and database management, and have a strong understanding of the data collected. Moving on to the technical department, which in first glance appears to be one of the departments mostly affected by digitalization. Some of these, as we said, already exist. A performance engineer to follow up and analyze the performance deriving from the sensors, performance records of the ships, evaluating and measurements of the records received, checking and monitoring effectiveness of dry docking once completed, and in-service performance and effectiveness of anti-fouling, as well as other systems. Advanced material engineer. Metal will remain a dominant material in the shipbuilding industry. However, it's been shown that it will be redefined through development and implementation of advanced materials, known as microscale and nanoscale materials, for ship structures and new coatings and anti-fouling. Remote monitoring engineering, development and implementation of new generation sensors, wireless technologies able to collect data from the ship autonomously and relay them in real time to the company for condition monitoring, reducing the need for regular visits on board, especially at remote locations. A drone manager. During routine maintenance, human inspectors can be replaced by drones in order to achieve increased safety, efficiency, and reduce costs. All data collected is then analyzed naturally by an offshore superintendent. This method of inspection significantly reduces risk to human life, especially during essential maintenance when it comes to enclosed space entry. Advanced power and propulsion technologies marine engineer. Development and application of advanced power generation and propulsion technologies, diesel, electric, and hybrid propulsion, with alternative fuels, energy-saving devices, renewable energy, and hybrid power generation units. New building projects and ship design. Design of eco-ships and green vessels to increase the speed and reduce fuel consumption. Experts in ship automation will be in continuous close contact with innovation teams in order to find new technologies and implement them to the shipbuilding of the vessels. For example, ballast-free or non-ballast vessels, reduction of CO2 footprint, reduction of GHG emissions, etc. Moving on to the operations department. This is a department where big data is currently being used and is extensively used for better voyage efficiency. Oh, we've lost something. Ah, there we are. We begin with a big data analyst. Analysis of data collected from various sources, such as oceanographic data, weather data, maritime accidents data, and voyage abstracts. In some cases, it's already happening. Cargo operations data in order to improve ships' daily operations. Evaluations of the detailed records regarding the sea passage, MRV emission reports, IMO data collection system, cargo operations and cargo sequences. Development of land-based control centers for remotely monitoring autonomous and semi-autonomous vessels. Drones are also connected to the operations department. As we know, ship agents in Europe have currently calculated that using drones for deliveries rather than launch boats can help reduce costs by up to 80 to 90% for vessel operators and ship managers. This is also better from a safety point of view, considering a traditional launch boat uses cranes, ropes, and climbing crew to deliver spare parts, even mail. A drone is less labor-dependent mode of delivery. Chartering department. the use of artificial neural networks allows the detection of significant correlation between freight rates and can aid in the future in the possible prediction of freights. Use of vetting platforms. RightShip is an example of a platform currently using predictive analytics as a way of evaluating a number of issues that may arise on a vessel. As we know, this has caused many issues and can be combined currently being combined with experienced marine personnel. Use of online freight platforms to enable online e-auctioning of vessels from the shippers, where the shippers compete for the transport of commodities. These innovative shipping platforms invite vessel owners and operators to bid in a real time and in a secure and confidential portal. This would lead to seeing vessels becoming the Uber of the seas, with ships sailing around and shippers able to hail the vessels serving their particular intended route. With the use of cargo matching platforms, which aims to provide a way for maritime companies to match the cargo with a ship. This is already being used and will be used a lot more extensively in the future. Moving on to the safety and quality and ISM department. Environmental, health and quality engineer. Following up of all these new regulations and evaluation for each particular company would need a particular engineer to do that regarding the environmental and marine pollution, CO2, SOx, NOx, ballast water treatments, use of LNG and hybrid fuels. Crisis and media manager, responsible for monitoring and managing emergency situations on board and ashore, a dedicated person who would be fully responsible to handle press inquiries and social media inquiries. A vetting manager. As we mentioned earlier, RightShip is currently, as well as other platforms, in the process of collecting this data. Apart from the preparation of the ship itself, a company would need somebody who would be able to evaluate that this data is correctly collected and correctly processed, since this is the data that its company is essentially judged upon. Supply and purchasing department. Collecting data is necessary in general to increase savings. This can be achieved, for example, by analyzing the following factors: inventory fluctuation and resupply volume of specific components, ports of supply and frequency of calling a specific port, shipment tracking and real monitoring available through websites and daily incoming data about weather forecasting, accidents, events, holidays that may have a negative influence on a shipment. Making better use of already available marine traffic information. This can be necessary for better decision-making in case there is lack of information regarding a vessel's ETA. I've highlighted 3D printing technology, and in our opinion, there would be generally need for companies that would be involved in 3D printing, as it's been used for critical spares on board ships in some companies already for a few years now. And with it comes the need for qualified personnel. There are a multitude of applications for 3D printing, like innovation of new products through rapid prototyping and improvement of already existing product designs. It also gives seafarers the opportunity to repair or reproduce obsolete parts on location. As a general note, 3D printing itself is expected to change the way goods flow into the market, in the container business, as well as the transport of raw materials. The potential effect of 3D printing production is reflected in investments in 3D printing technologies in other sectors, such as engineering, automotive, and consumer goods sectors. Many items will no longer have to be shipped, as they will be printed on location, whereas the actual commodity traded in the future will be the digital pattern for the item itself. Moving on to the crew department, we'll have a marine personnel business analyst responsible for creating and keeping updated electronic data in the company's current pool, together with all CVs, crew readiness certificates, as well as adjusting automated crew planning system. Furthermore, what we currently know as a crew manager will probably be separated into two particular positions: crew change operator, which would be responsible only for the crew changes, agents, tickets, visas, etc., collaborating with a marine personnel analyst to monitor the movements of the crew in real time, sharing their location with the crew department on board, joining repatriation in order to ensure crew safety and avoid delays. Crew Performance Evaluator would arrange psychometric tests for people on board and ashore, discussing and evaluating the complaints of the seamen in order to improve the quality of the company's pool. Naturally, he would also keep and update the electronic evaluation system of the seamen. Legal and Insurance Department. In respect of the digitalization of the legal and insurance sector of the maritime industry, some areas will be legal databases, the further advancement of existing and extensive use of existing online legal platforms, and other legal databases of commercial law knowledge from trusted legal sources, arbitration awards, court decision, etc., and their subsequent real-time sharing. And secondly, insurance, as blockchain applications may offer various benefits such as smart insurance cover contracts, automated claims for fewer processing delays, and lower transaction costs. Increased back-end efficiency, less human error, no data duplication, and fewer processing delays are some of the benefits. Better pricing and risk assessment, new types of insurance with more transparency and less costs. And it appears that we will be seeing the first cover on blockchain in 2018. This may offer the benefits of quicker processing, but is open to cyber threats. It remains to be seen whether automation will benefit the insurance sector, which requires personal interaction and input in difficult situations. The difference between the marine insurance sector and other insurance sectors is that the actual risks, the vessels sail and go around the globe and go towards the risk, whereas in other sectors the risks come to the assets. In order to summarize, I'd just like to point a few things to say that digitalization is one of the, as we said earlier, one of the most important issues facing the maritime industry today. It's expected in general to improve business results by decreasing operating costs and improving efficiency of operations. However, the road isn't without challenges. There seem to be some hotly debated topics that digitalization brings along. One of them is a legal debate of transferring the responsibility previously held by the vessel, the crew, and ultimately the master, to the ship manager and the office staff, who now have the capability, and ultimately the responsibility to make real-time decisions and monitor various types of alerts in the office rather than the ship. Also, online bidding platforms have caused a surge in people evaluating and re-evaluating the need for brokers, their physical presence and knowledge in the industry. As I mentioned earlier, human adaptability will be key to integrating these innovations within existing structures. This would mean extensive training, which may lead to previously unknown issues, as well as risk assessment relating to the management of change. An important paradox to consider, however, is that although the human element may appear in instances such as this to be the weakest link, it is the human element itself, whether it is that of mariners or of people who have dedicated their life to the industry, that must not be bypassed by data and numbers, overriding years of experience. Shipping is an industry which many times relies on people thinking outside the box and taking decisions that a system may be incapable of doing, now, in the past, or in the future. At this point, I would like to borrow an anecdote used by Mr. John Platzidakis the other day, chairman of Intercargo, at the Lloyd's List business briefing, who reminded the audience on a similar debate that during the first moon landing, Neil Armstrong had to manually override the malfunctioning landing computers in order to take controls and land Apollo 11 on the moon's surface. It is obvious, therefore, that while the digital revolution is paving new roads for everyone, many hurdles have to be surpassed for a smooth transition to the future. Thank you very much and welcome.